let's look at how we can decrypt the Playfair cipher. This is the code from the last video where we have implemented the encryption of the Playfair cipher. And I think looking at how the encryption and decryption process goes, it looks like it's relatively easy to reverse. And rather than starting from scratch, we are actually going to use our encryption code and modify it so that it does decryption. It does the decryption for us. In the last video, we used the plain text hide the goal in the tree stump, and using the key Playfair example, it was encrypted into this ciphertext, which cannot be pronounced. So we are gonna work with the ciphertext, and we wanna hope that by decrypting it properly, we'll get back the plain text hide the goal in the tree stump. So let's get started. First, let's take a look at rule number one. So the purpose of rule number one is to remove the possibility of letters that are the same, pairs of letters that are the same, and also to deal with the scenario where the last letter in the sentence does not have a pair. So for decryption, we actually do not have to go through this rule, right? And so all we need to do would be to just split our ciphertext into pairs of characters. Right, so let's do that. So I'm just gonna, I'll leave the apply rule one comment here, and what I'll do is, there's no need for this text. We'll just combine this with this. So we know for a fact that our ciphertext will always be an even number of characters. So we really don't have to worry about an odd character at the end, and we don't have to worry about this. And we'll just append to our ciphertext pair the letters A and B, and we are always incrementing by 2. Okay. All right, so let's take a look now at the next 3 rules. So we are now going to work on ciphertext pairs. Do we need the apply rule variable? I think we do. So we are going to leave that there. Now, rule number 2, if the letters appear on the same row of your table, then replace them with the letters to their immediate right. So we'll know that if the plain text pair is in the same row, the ciphertext pair will also be in the same row. So we are fine with that, right? But now, instead of replacing them with the letter to their immediate right, we want to replace them with the letter to their immediate left. We've done this before with scissor cipher, but it's worthwhile going through it again. One thing we can do is we could use do -1. So rather than to the right, you're going to the left. So you, rather than adding 1, you subtract 1. The problem will be, and let me pull this up. The problem will be if we get something which is on the left hand side. Let's say we get the letter I there, right? To the left of I is nothing. So we will need to wrap that over to the right hand side. So we will need to make this code more complicated so that it will handle the case of a negative number. But we're not going to do that. What we're going to do instead is, rather than subtracting 1, we are going to add 4. And that's because we are working with this new circular math or modular arithmetic. So subtracting 1 is the same thing as adding 4, mod 5. Let's take a look at rule number 3. So same thing, if the letters appear on the same column, if the plain text letters appear in the same column, the ciphertext letters will appear in the same column. So we can still do the same test to see if they're in the same column, and rather than replacing them with the letter immediately below, we want the reverse process will be replacing them with the letter immediately above. And we also want to make sure we handle the case where the letter is already at the top row. What happens is that we need to wrap it to the bottom if needed. And we don't want to work with negative indexes. That's going to make the code more complicated. So rather than subtracting 1, we're going to add 4. So this is exactly the same thing as rule number 2. Right, so that's done, and now let's take a look at rule number 4. So if they're not in the same row or column, we'll do a replacement like this. And in fact, this operation is reversible, meaning that if I had the letter HI and I encrypt it, it will become BM. But if I had the letters BM and I encrypt it, it will become the letters HI. So actually, I do not need to change any code here. It's going to just applying the encryption algorithm again, encryption rule again is going to find me the original. And right. So, but one thing that we need to do that I have forgotten is we are actually going to have to replace all the references to plaintext pair, ciphertext pair to plaintext pair. That's one, because we are doing the going in the opposite way. And we are not appending it to the ciphertext pair, we are appending it to the plaintext pairs. Okay, let's not print that out. Right, so let's print out our ciphertext. And let's print out our plaintext pairs. And we'll see whether that works or not, or whether there's a mistake in how we implement it. So there's an error here. That's one where for rule number 1, we are not going to the plaintext, and that doesn't exist. It has been commented out. We are actually going to work through the ciphertext. Run the module again. Right. I have to look inside too and make the changes here. Okay, let's just take a look. Everything looks okay. Let's run it. Wait. There's a spelling error here. I'm missing a T. Oops. Oh, there you go. Right, so our ciphertext will produce this plain text, hide the goal in the Texas thumb. And the reason why there is this X here is because the letter E was repeated and it had to be separated by another character. In here we chose X. And we wouldn't be able to, in our decryption exercise, we wouldn't be able to really figure out whether this X is a valid X that should be in a message, or it's an X that was inserted as part of the algorithm for the Playfair cipher. So we'll just have to keep it in there, and the person reading the plain text will have to manually remove all the padding characters. But as you can see, it's been relatively easy to come out with the decryption algorithm by modifying just slightly the encryption algorithm. Essentially, what we did was for rules 2 and 3, rather than looking at the letters to the right and below, we are looking at the letters to the left and above respectively.